Summary. The main features of this chapter which we have studied are as follows. Integration is the inverse process of differentiation. In the differential calculus, we are given a function and we have to find the derivative or differential of this function. But in the integral calculus, we are to find a function whose differential is given. Thus, integration is a process which is the inverse of differentiation. Let d by dx of capital Fx equals small fx. Then we write integration small fx dx equals capital Fx plus c. These integrals are called indefinite integrals or general integrals. C is called the constant of integration. All these integrals differ by a constant. From the geometric point of view, an indefinite integral is collection of family of curves, each of which is obtained by translating one of the curves parallel to itself upwards or downwards along the y-axis. Some properties of indefinite integrals are as follows. Integration fx plus gx dx can be written as integration fx dx plus integration gx dx. For any real number k, integration k fx dx equals k into integration fx dx. More generally, if f1, f2, f3 up to fn are functions and k1, k2 up to kn are real numbers, then integration k1 f1x plus k2 f2x up to kn fnx dx equals k1 into integration f1x dx plus k2 into integration f2x dx up to kn into integration fnx dx. Some standard integrals. Integration x to the power n dx equals x to the power n plus 1 divided by n plus 1 plus c, provided that n is not equals to minus 1. Particularly, integration dx equals x plus c. Integration cos x dx equals sin x plus c. Integration sin x dx equals minus cos x plus c. Integration sec square x dx equals tan x plus c. Integration cosec square x dx equals minus cot x plus c. Integration sec x tan x dx equals sec x plus c. Integration cosec x cot x dx equals minus cosec x plus c. Integration dx divided by root over 1 minus x square equals sin inverse x plus c. Integration dx divided by root over 1 minus x square equals minus cos inverse x plus c. Integration dx divided by 1 plus x square equals tan inverse x plus c. Integration dx divided by 1 plus x square equals minus cot inverse x plus c. Integration e to the power x dx equals e to the power x plus c. Integration a to the power x dx equals a to the power x divided by log a plus c. Integration dx divided by x into root over x square minus 1 equals sec inverse x plus c. Integration dx divided by x into root over x square minus 1 equals minus cosec inverse x plus c. And integration 1 by x dx equals log mod x plus c. Integration by partial fractions. Recall that a rational function is ratio of two polynomials of the form px divided by qx, where px and qx are polynomials in x and qx is not equal to 0. If degree of the polynomial px is greater than the degree of the polynomial qx, then we may divide px by qx so that px by qx equals tx plus p1x divided by qx, where Tx is a polynomial in x and degree of P1x is less than the degree of Qx. Tx being polynomial can be easily integrated. P1x divided by Qx can be integrated by expressing it as the sum of partial fractions of the following type, as it is shown. Integration by substitution. A change in the variable of integration often reduces an integral to one of the fundamental integrals. The method in which we change the variable to some other variable is called the method of substitution. When the integrand involves some trigonometric functions, we use some well-known identities to find the integrals. Using substitution technique, we obtain the following standard integrals. Integration tan x dx equals log of mod sec x plus c. Integration cot x dx equals log of mod sin x plus c. Integration sec x dx equals log of mod of sec x minus tan x plus c. And integration of cosec x dx equals log of mod of cosec x minus cot x plus c. Now integrals of some special functions. Integration dx divided by x square minus a square equals 1 by 2a log mod x minus a by x plus a plus c. Number 2. Integration dx divided by a square minus x square equals 1 by 2a log of mod of a plus x divided by a minus x plus c. Number 3. Integration dx divided by x square plus a square equals 1 by a tan inverse x by a plus c. Number 4. Integration dx divided by root over x square minus a square equals log of mod of x plus root over x square minus a square plus c. Number 5. Integration dx divided by root over a square minus x square equals sin inverse x by a plus c. And integration dx divided by root over x square plus a square equals log of mod of x plus root over x square plus a square plus c. Integration by parts. For given functions f1 and f2, we have integration fx gx dx equals fx into integration gx dx minus integration f dash x into integration gx dx dx. That is, the integral of the product of two functions equals first function into integral of the second function minus integral of differential coefficient of the first function into integral of the second function. Care must be taken in choosing the first function and the second function. Obviously, we must take that function as the second function whose integral is well known to us. Integration e to the power x into fx plus f dash x dx equals integration e to the power x fx plus c. Some special types of integrals. Integration root over x square minus a square dx equals x by 2 into root over x square minus a square minus a square by 2 log of mod of x plus root over x square minus a square plus c. Number 2. Integration root over x square plus a square dx equals x by 2 into root over x square plus a square plus a square by 2 log of mod of x plus root over x square plus a square plus c. Number 3. Integration root over a square minus x square dx equals x by 2 root over a square minus x square plus a square by 2 sin inverse x by a plus c. Number 4. Integrals of the types integration dx divided by ax square plus bx plus c or integration dx divided by root over ax square plus bx plus c can be transformed into standard form by expressing ax square plus bx plus c as a into x plus b by 2a whole square plus c by a minus b square by 4a square. Number 5. Integrals of the types integration px plus q dx divided by ax square plus bx plus c, or integration px plus q dx divided by root over ax square plus bx plus c can be transformed into standard form by expressing px plus q as a into d by dx into ax square plus bx plus c plus b, which is equal to a into 2ax plus b plus b, where a and b are determined by comparing the coefficients on both sides. We have defined integration a to b fx dx as the area of the region bounded by the curve y equals to fx, x between a and b, the x-axis, and the coordinates x equals to a and x equal to b. Let x be a point in the closed interval a comma b. Then integration fx dx with the limits a to b represents the area function ax. This concept of area function leads to the fundamental theorems of integral calculus. First fundamental theorem of integral calculus. Let the area function be defined by ax equals integration a to b fx dx for all x greater than equal to a, where the function f is assumed to be continuous on the closed interval a comma b. Then a dash x equals fx for all x belonging to the closed interval a comma b. Second fundamental theorem of integral calculus. Let f be a continuous function of x defined on the closed interval a comma b, and let capital F be another function such that d by dx of capital Fx equals small fx for all x in the domain of f. Then integration a to b fx dx equals fx plus c with the limits a to b, that is equal to fb minus fa. This is called the definite integral of f over the range a comma b, where a and b are called the limits of integration, a being the lower limit and b being the upper limit. That's all. Surely you would have loved the chapter and mastered all the techniques.